What? Sorry.
All right.
Okay. Any questions on the homework? That's a change. Yeah, sort of, right? Just the co-function thing was the really only new thing, but it was pretty straightforward. It wasn't anything that challenging. All right, make sure names are on them, pass them left. Let's see, where do we stand with the calendar? Why is this not clicking?
Quiz next Wednesday. Test next Wednesday.
That's not you. That's not you.
Oh,
this is
Thursday.
you.
Wait, did it get moved?
After 8 tests next week?
That's so soon.
Yeah.
Because there's only 4 sections in chapter 8.
Yeah.
So I had the option of giving a quiz, but that seemed kind of ridiculous.
Sure.
We're not skipping anything. There's only 4 sections in the book. Okay. All right.
That's really good.
So today we're going to do something that also doesn't introduce anything new. Like nothing new. There's always a but, right? They're all word problems, right? So they're going to be trig problems that are word problems, Julia's favorite, right? So in order to do, I didn't have a conversation with Ken. When did we say we're taking the test? Okay. So I truly don't need to show you anything. You could do the homework right now. I will show you. We'll do a bunch of examples, but I'm saying you could do this homework without any input from me. There's nothing new. There's no new technique. The very last question, and I did give you one, is weird. It's not weird because it's the trig. It's weird because it involves aviation and how they do directions in aviation. So I will explain that one to you. And yes, I mean, I debate every year whether to give you this one problem, but it's weird enough that I'm like, they should be at least exposed to this. So if they ever run across this ever on an SAT question, possibly, right, that they've at least seen this concept. It's a pretty straightforward concept. It's just you may not figure it out all by yourself. All right, homework. And then for Chloe and Elena, if Elena actually sends me her email so I can send this to her. I'm going to do a little bit of drawing on the board, but not much. So unfortunately, you guys won't be able to see what I draw, but I will show you a perfect diagram of every word problem that we do. It's just that I'm going to have the students come up with their own drawing, and then we'll match it to what's in the book. And usually what happens is it matches perfectly. Yeah, because they're all word problems, so the answers are really intense. So the answers are... All right, everybody ready? There are 6 problems we'll do. The last one, number 6, you should be able to do 1 through 5 all by yourself. Although, how many people remember angle of elevation, angle of depression? Yeah, but you probably could take a guess at that one. The very last one, number 6, I'm assuming it's number either 72 or 74 for tonight for homework. I do need to show you that one. Ready? All right, here we go. So it's applications. Applications are just how we say word problems. In other words, word problems, yeah. I ever have a kid that's poorly behaving. Did any of you guys throw a temper tantrum?
Yeah.
Okay. All right. All right, that really ticks me off when I'm in a store and some kid just throws a temper tantrum and the parents do nothing. What are you teaching your kid? Quick review on the basic trig. Hopefully this is not necessary, but I'll do it anyway. The basic trig always involves right triangles. Now we know we can use trig and it doesn't have to be a right triangle. The rest of the chapter also, starting on tomorrow, deals with non-right triangles. Do you remember doing laws of sines, laws of cosines? You did it less than a year ago. In fact, you did it 5 months ago. It was on the test that I gave you.
When? What?
I got it in my desk right now. I can pull it out and
The
show
one
it
that
to you.
you gave me after we came back from summer?
It had law of sines and cosines on it. Okay. Anyway, you did this last year in Algebra 2, so it's kind of a review. We will add a little bit more complexity to it, but that's coming up. So we're still in the world of right triangles. Trig does a very good job of solving that. The only difference is we get to pre-calc, we consider that the right triangle is placed on the unit circle. Today, they're real world problems, so no unit circles involved. Not that should make it any more complicated. We get 6 basic trig functions. There they all. This is all review from yesterday. And this was kind of an explanation of where this x over r, x over y, or y over x, where all that stuff came from. The only thing is you can get yourself into a little problem when you're doing problems from the textbook, not tonight, but last night's homework. If you draw your right triangle, say in quadrant 2, it still would work, but your A and your B might not be in the right spot. So as they draw their standard position right triangle, they put the A as the bottom part of the right triangle. C is always the hypotenuse. So that's where they get these values. And by the way, they could have named it any letter of the alphabet they wanted to. The X and the Y have a specific meaning, so does the R, but the A and B are kind of arbitrary. There's 2 basic procedures of basic trig, and that's solving for an unknown side and solving for an unknown angle. Solving for an unknown side, they must give you one angle and one side. It could be any angle, it could be any side other than the 90-degree one. So I guess technically they're giving you 2 angles, but just one unique one from the 90-degree angle. If you have a side and an angle, you can solve for any one of the 3 sides. Solving for an unknown angle, you have to have 2 sides. I guess they could give you one side if it was isosceles right triangle, but technically they're still giving you 2 sides. So what's the procedure? Well, remember, solve for an unknown side. You use your basic 6 trig functions. Most people only use sine, cosine, tangent, SOHCAHTOA. And if you're solving for an unknown angle, this is when you use your inverse functions. And you guys have just done 2 chapters of this. This is not, anything new to you. So this is the problem we had from yesterday. Just quick review. You told me that there's no way in heck you're ever going to use trig to solve for beta if they give me one of the angles. I agree, but you certainly could use trig to solve for beta. To solve for C and A, then we simply use one of the 6 known trig functions. I'm solving for C. I could solve for A. So let's see, a relationship to 40 degrees. C is the hypotenuse and 2 is the adjacent, which is why we're using cosine. And you do a little bit of algebra and you get to the answer. Yes, I'm going over this quickly because this isn't new and you've done it for 2 chapters now. To solve for the unknown side, A, I'm just throwing you the answer for A. To solve for the A value right here, since we already know 2, it would be a tangent function, so forth and so on. Solve for an unknown angle. Remember, we're going to use inverse. We use inverse because as you set this up algebraically, solving for beta, then you got to get rid of the word tan, and the inverse of tangent is inverse tangent. We're usually lazy. We don't write inverse tangent of both sides and cancel. We simply go right to, I did it right there, but most people go right to the fact they know that if they take the inverse tan of both sides, then on the left side, inverse tan and tangent cancel, and you're left with beta. And on the right side is what you type into the calculator. Okay, good enough review? All right. You will be using this to answer every question tonight for homework. You're either going to be solving for an angle or a side or a combination of both. You are free, if they give you 2 sides, use Pythagorean theorem. You are free to realize that if they give you one of the angles, and it's a 90-degree angle, you don't need to necessarily use trig to get to the 3rd angle. All right. Have I confused anybody? No. All right, cool. So today's class is just work problems. We're going to do 6 examples. I chose 6 examples that are very similar to the ones that I assigned you tonight for homework. The way I typically teach this is we'll go over the problem bit by bit by bit. We'll draw what we think the picture looks like. Don't spoil it and look ahead in the book. We'll draw what we think it should look like, and then I'll show you what the diagram is in the book that illustrates the problem. And usually we wind up with the same picture. In fact, I should say, I hope. The only challenge with this entire process is you got to draw a picture, right? All right. Look at the text of that. Look at the font of that, how small that is. So there's a lot of words. It's in front of you right now. One of the issues we get to higher level math is they don't make like little Johnny is on a swing or something like that. They usually use big words, and sometimes the words you don't even understand what they are. So Google is your friend. Anybody see a word there you don't know? Do you know what a transit is? Anybody? What's a transit?
Is it just weird, like tripod things, like sit ups sometimes?
Yeah, it's that thing. So what's a transit? That's the only thing that's probably understood. That's a transit right there. And a transit is just a big fancy, does a lot of things. It's a big fancy protractor, except it's got a telescope on it, right? It has some more features as well too. It just basically tells you angles. It'll tell you angles left and right and up and down, right? And transits usually come along with somebody whose job literally is to, you've seen this person before. What do? They hold a stick. Someone's getting paid good money, probably not that good, I assume. Usually what my assumption is that's the apprentice, that's the person in training. This is the experienced person, the guy that holding the $10,000 device, and the person that holds the stick is the person probably learning. But I could be wrong. Maybe somebody literally gets hired to hold a stick. They hold a stick, you look through the eyepiece, you focus on the top of the stick, and then you read what the device says. It'll tell you angle left and right from true north and up and down. And that's what it does. A lot of these have range finders. They'll tell you distances as well, too. Surveyors use this to, hey, we got to make sure the building gets placed in the right spot. All right, so let's see. A surveyor can measure the width of a river by setting up this thing, a transit, at point C on one side of the river and taking a sighting of point A on the other side. Confusing or not confusing? By the look on Julia's face, it's super confusing, right? So you read it 3 times, and then by the 3rd time, you're like, okay, I understand that I probably need to draw a what?
A river.
A river. So how are we going to draw a river? Left to right or up and down or diagonal? Your choice. You want left and right? So unfortunately, Chloe, you'll see the picture at the end. They're telling me I need to draw it from left to right. Okay, there's your river. Why are you?
I'm just looking at you.
I know, but you got this look on your face like I'm nailing nails through your. All right. So a surveyor sets up a transit on one side of the river. Which side? One side. So clearly you now need to. Okay, so I said, so clearly you need to pick a point on one side of the river. All right, you got 2 options. There's no left or right.
What do you mean the left side?
The rivers, this would be called a lake if it wasn't a river, right? Lakes kind of sit there, but rivers continue in one direction. So left or right's continuing forever, let's say. Jackie says she wants to go with what? The top. So she's going to put her point, and I'm going to put a little dot right there. We're going to call that C, right? Julia? Okay, she's good with that. All right. Now what? A is on the other side. Does it say where it is? No. Okay. Well, at least from that first sentence, we don't know necessarily other than A is on the other side, right? If we read the second sentence, though, it says, well, it says, after turning through an angle of 90 degrees, so they're looking at 90 degrees. This is where you kind of figure out that.
It's a right triangle. Wait, so is it down? And then
Yeah. So that, like I said, the trickiest part is just reading the text. So the first issue was, where do we put A? Is A, oh, you can't see what I'm doing. I'm pointing way to the left. No. Is A over here? Is A over here? Or is A directly across? Directly across. And the only reason we know that is because it says after turning it 90 degrees. So if you're looking straight down, right, that would be perpendicular to the river, right? Mm-hmm. Okay, so there's your point A. After turning 90 degrees, what, left or right, or does it say? It doesn't. It doesn't say. So after turning 90 degrees at point C, the surveyor walks a distance of 200 meters to point B. Does it say he walks across the river? So I'm assuming he's walking. Now we got to pick again. Does he walk left or right? She says pick right. So after walking a distance of 200 meters, he's now at point B. So from here to here is 200. We know that this is an angle of 90. The surveyor walks a distance of 200 meters to point B. Using the transit at point B, angle theta is measured and found to be 20 degrees. So what am I drawing? Okay, and where does the 20 degrees go? Okay, do I need the river now?
No.
So it kind of gets in the way, but there's your picture, right? What's the question ask?
What's the width of the river?
So the one assumption that we're making right here is that A and C are actually like literally on the water, not in the water, but just right on the edge of the water. So the way I drew it right there is, you know, I probably need to put A right there. Am I going to do that? No, that's good enough for me. There's your picture. Do you agree that if all I had on a piece of paper was this, you would say, what's the big deal?
Yeah.
There's your difference between a word problem and a non-word problem. In a non-word problem, they literally hand you everything. In a word problem, you're making that shape itself. So careful, close reading. There's a little bit of interpretation here. I had to decide left, right, up, and down. But anybody going to argue with the picture? Right? In reality, is this one I just drew right here? Could I get to the answer from that? Okay, so what am I using? Oh, I didn't label 20, did I? So what am I using? In relationship to 20 degrees, what's X and what's 200? Adjacent and opposite, so that's tangent. So this whole big problem is just tangent of opposite over adjacent, X over 200. All right, you want to see the picture in the book? Click, 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 click. There's the picture in the book. So what's the difference? I mean, the only difference was is that our triangle is, we picked point C on the top and they picked point C on the bottom. That's literally the only difference. Okay. In reality, can I erase the picture now? In reality, this makes it way more complicated as a word problem than it is as a math problem. All it is a tangent. So we throw that into our formula. I will insult your intelligence and ask you, what do you do next? What do we do next? Sadie? What do we do next? Okay, that would imply okay, so we multiply both sides by 200. So it says B, which is the distance here, is 220. So you should grab your calculator and make sure you are in degrees because they gave me degrees. Does it say, oh, it says round to the nearest meter. So the answer is 70, 73 meters. That's what I got to. Isn't there just a way of making a really easy problem into a complicated problem? Julia's physically shaking right now.
Can I solve the next one?
That is the question. All right, we okay on that? All right, I would say in the order of complicated to, or least complicated to most complicated, this is the least complicated one. It's pretty straightforward. I'm not sure how you could screw this up, right? Other than a math error, but I'm saying like it's the things that are more challenging is when there's a little bit of interpretation that you have to do that's really challenging. There was nothing here that we really was challenging. Okay, you draw a river. I don't think anyone's going to draw a river that doesn't look like that, right? Like, do they draw a circle for the river or something like that? They're confused whether you're talking about radius or diameter. No, not in this particular problem. So this was pretty straightforward. We okay? We're doing 6 of these. All right, next one. Ooh, not many words. Me? Are there any words up there you don't understand? There should be one. What? Inclination? Okay. Manitou Springs has a, literally it's called incline because
Scenic.
Goes up.
Oh, scenic means it's nature, it's beautiful to look at. How about grade? What says grade means inclination?
Grade is an angle.
All right, how many people, when you gone skiing or you gone to the mountains, you've actually paid attention when you're driving, or is your head in your cell phone is normal? What do you see on the side of the road?
It says grade and then it says.
It literally says grade and it has a percent next to it. It says, hey, it's a 5% grade or something like that. That's the inclination of the hill you're going up or down, right? You ever seen those things for the trucks when you're driving through the mountains?
The runaway.
Yeah. I have a question.
Like that's a no joke thing. They have.
How was Paula?
On one, which is never.
Yeah.
happened.
What?
How was Paula in PreCalc?
I ask that question every day.
You want me to be
Want to
honest
know
with
what
you?
you just said?
I cheated on the NWBA.
That's not what got you into PreCalc. I
What's that original?
taught you the other classes. Okay, here we go. So Landon said he was doing this. So what do we need to draw, Landon, after reading it?
Triangle. Or no.
What are we going to draw first?
Draw the trail.
Where's the trail?
It's straight in the Alpine Hotel.
So probably I should draw first.
The whole hotel.
How do you want me to draw the hotel?
Put 2 squares and then
Just draw a
build
house.
like a few windows.
Why am I drawing 2 squares?
To make it really detailed.
Oh,
We don't need.
Why are
those
we
to be
driving
detailed.
this?
Did you know?
right. So there's my hotel. Now what?
Draw the path.
Which way does the path go?
It doesn't really
I'm
matter.
sorry, I won't make.
Yes, it does.
It's a straight
Where is the path going?
to the hotel.
Going up.
It's going from the hotel.
To a scenic overlook.
Okay. Now you have to make an assumption here. It says the Alpine Hotel has an elevation of 8,000. The scenic elevation is.
So it's going.
So are we going up or down?
And then why?
So where do you want me to draw the scenic overlook? And how am I going to draw the scenic overlook?
So you see the bottom right of this.
Draw a
one?
mountain.
Just go like this way.
Okay. But the first thing I'm going to draw is
Okay.
it's a scenic overlook. There's got to be a flower up there. What are you looking at once you get up there? I don't know.
Trees. Draw a tree.
It took me a long time. Okay.
The worst.
That is not the right time to tell.
It looks like SpongeBob glove.
Broccoli. Right. So there's my
There
trail.
you go.
Now what?
Add
Draw.
3,000
You
feet.
gotta make the.
Put 3,000 feet on the
No,
trail.
you gotta make
No,
it.
the trail is
Nice.
14,000. Yeah, this is
Wait.
14,000.
This is like
And then on the.
Oh.
kindergarten.
Says the trail length is.
But it goes
Y
up
is
3,000.
And then we're looking for X. Wait, no, we're not.
So is it going to be the hypotenuse or is it going to be the leg? It's 14,000.
Leg.
Because you're walking the trail and the trail is the hypotenuse.
It's the resultant. The leg is 3,000.
So 14,100. Now what?
Now you draw from the tree down.
So the tree down.
Keep going, keep going, keep going.
No.
And then go back.
So you're making a,
Square, there's triangle kind of.
okay.
We're making a
That's
square.
3,000.
Yes, very good.
Sorry.
Now, a lot of people, because they give you 8,000, 11,000, we're going to use those numbers.
Yeah.
It's 3,000.
The reality is the 8,000 is
Down there.
where
See.
sea level is, right? So this is your 8,000. This is,
3,000.
Okay.
3,000.
so what does it ask?
It's asking for the leg.
For the angle.
Where's the question mark?
What is the inclination grade of the trail?
So it's actually asking us for the angle. Is it this angle or is it this angle?
This angle.
You think about our incline as we're going up, right? It wouldn't be the angle going down, it would be the angle going up. So our theta, what we're solving for is that. So there's your picture, yes? You think it matches what's in the book?
Sine, you're using sine.
Hey, that was pretty darn close. Why do they say 3,100 and we wrote 1,000?
That is not very scenic.
Okay.
Wait, it's 3,100.
Oh,
we
we
left it in
No, Mr. C never noticed that he actually typed in the wrong number.
That's wild.
And why is this the third here and I just don't noticing it right now?
That's crazy.
Okay. So next year will be better, but yes, the math here is basically the same, except that clearly I have a mistake. I should have put 11,100 right here. Okay. We okay? All right. So what are we using? I'm gonna erase what I've done.
Sine, we're using sine,
So we have the opposite, we have hypotenuse, so we're using sine of beta is equal to
1400 and 100.
opposite of hypotenuse.
Yes.
That's a hypotenuse, so that'd be on the bottom.
Okay.
And then 1300. What?
All right.
Hey, look, I used the right number in my calculation. All right. And then Tammy said, wait a minute. You guys are doing extra work because we know how this works.
Sine -1.
Inverse sine is how you get rid of the word sine of both sides. So she's saying we can immediately just jump to, okay. It doesn't say round to the nearest tenth, but I did.
Wait,
Everything
you
is,
still put it
everything is
wrong.
right in the wrong thing.
Wait.
Say again?
Those are the wrong numbers.
Where?
You got a lot of
Isn't it
things
still
wrong.
3,000?
No, I said that, I mean, that's the mistake right here, but it's still, the real number is 3,100.
No, you're not.
If I had typed in the right number to the problem, I would have said 11,100, subtract 8,000, you get 3,100. Okay. Where are we at for this one? Easy, medium, or challenging? This was pretty straightforward. Okay, so we're at this statement right here. I need to solve for theta, so how do you get rid of the word sine? That's what you do the inverse, right? Both sides of the equation. As Cammie said, she's not even going to write this because most people do this. Like, well, I know how this story goes. And so writing this step that's right here is like a pain in the butt. So most people say, well, I know what I need to do. If I'm solving for the angle, I got to use inverse sine. But I always point out that that's the actual algebra that gets you to the answer. Okay, 6 examples. That was 2. Have we gotten anyone that was challenging yet?
This is a banger.
Okay.
Like me.
Okay. Here we go for the one. Remember I said I was going to introduce something that you remember from geometry. So in geometry, we had angle of inclination and angle of depression. Do you remember doing those two? Or you remember the words, right? Yeah. Okay. And I told you that when you have these angle of elevation, angle of depression problems, that you must always remember to look where first. If you do anything with angle of elevation, angle of depression, where must you look first? You must look straight out to the horizon, right? Always remember, whenever you see angle of elevation, angle of depression, the first line you're going to draw is straight out to the horizon. Do not look at your target. If you look at your target, I'll show you an example here. You end up drawing the triangle incorrectly, okay? So I've got 2 points here, A and B, right? If I'm standing at A and I want to do something to B, clearly I'm using the angle of, to get from A to B, clearly I'm going to use the angle of elevation because I got to go up. But you must always draw your first line to the horizon. So if I'm at A, I'm not going to draw a line up to B because then it would make you think that the triangle looks like that. And that ain't the angle of elevation. Right? You must always, angle of elevation, depression, draw your first line to the horizon. Then, from here, move up to B. So that right there, that's your angle of elevation. Does that make sense? Conversely, if I'm at B, and I'm looking down to A, the first line you draw is not the line that goes from B to A. Your first line is going to be straight out to the horizon. Then you go down. That would be the line that's drawn there between A and B. And so that is your angle of depression. Kids will screw this up all the time because they'll just like, I just want to go right to the target. Don't do that. Go to the horizon first. Angle of depression, angle of elevation. Makes sense? And by the way, you saw this in geometry. Okay. Clearly that forms a right triangle, right? Notice beta right there ain't the angle of depression. It's not even close to being. In fact, it's 90 degrees off or I should say it's complementary to the actual angle. Angle of depression is right here. It's complementary to that angle. It won't be the same one, right? Angle of elevation is correct. Beta is not the angle of depression. In fact, it doesn't even have a name, right? Same thing for here. Beta is not the angle of elevation, right? I did this again, but do you guys get the basic idea? Okay, I won't do it again. All right. Oh, no. Once again, there's probably going to be some words there you don't know. Tonight for homework, if you encounter a word you don't know, just Google it. Look at it, right? They're going to give, it's a real world problem, and it probably involves something you may not have ever heard before. In this case, it involves a ceilometer. You have to be a pretty strange person to know what that is. If you take pilot training, you'll know what it is. A ceilometer literally measures, except in aviation, the ceiling is not the ceiling. The ceiling is where the clouds start. That's what's called a ceiling in aviation, is hey, where's the first cloud, right? Hey, if you have no clouds, no ceiling, right? You have clouds, you got a ceiling.
You also use that in fire a lot.
You could use that in other applications as well, too. So a ceilometer, like, I don't know what that is. So tonight you Google it and you come up with, there's your ceilometer. A ceilometer shoots laser beams or some light up to the clouds, and then it has a measuring device that looks for the reflection. And then it does a little bit of trig, which you will be doing, and it calculates the distance. It's still going to be a right triangle. Okay. All right. So let's see. Meteorologists, those are scientists that study meteors. For those that have taken astronomy, know that meteors are anything in the atmosphere, not just the rocks that fall from space. Anything in the atmosphere is a meteor, right? Find the height of a cloud using an instrument called a ceilometer. A ceilometer consists of a light projector that directs a vertical beam to a cloud base and a light detector that scans the cloud that looks for the light beam. Midway is the name of the airport in Chicago. A ceilometer was employed to find the height of cloud cover. Hey, first three sentences tell us a whole lot of nothing other than the fact that you got a beam shining up, right? The first three sentences don't set up the problem other than the fact that you're at a Chicago Midway. That has nothing to do with the problem. I'm going to take a video of you.
Oh, I'm just reading. I swear.
Okay. It was set up, it's light detector 300 feet from the projector. So you got a projector and you got a detector, and they are. So what do you want me to draw? How long is the line? Technically, it's a segment. So what's at the end of each one of these? Points. And the first one we're going to call whatever you want. You can call it the L for light and D for detector, or A and B, whatever you want. Okay. I'm going to say L is the light. Where's the light shining? Up. So the light shines up until it hits a. So there's my cloud. And then the detector is looking at the clouds for the reflection. So I need to draw now a. Okay. If the angle of elevation from the detector, where's the detector, to the cloud base is 75 degrees, is that an angle of elevation?
Yes.
Did I look to the horizon first and then up? Okay. If I had drawn the triangle the other way, that wouldn't be. But yeah, so that's 75 degrees. What's the height of the cloud cover? So where do I put my X? There's your 7. Okay. With the exception of the word ceilometer, this is a pretty straightforward one. Let's see if we match our picture. Hey, look, we're just backwards. All right. But yeah, they called their X an H for height. That kind of makes sense. Okay. Notice off to the side here, they're like, hey, that picture is just confusing. Let me just draw the triangle. So a lot of kids will just draw the triangle to start with and just plug in the numbers. Remember, the triangle itself is just kind of sitting there as a placeholder to help us understand what's going on. All right. Everybody okay? Example number 3. So what am I using? I'm using our friend. tangent is used a lot, especially when you're dealing with height, right? So we're going to use tangent. So tan 75 is equal to opposite over adjacent. So they used H, we used X. Therefore, Sadie, and basically you're done at that point. You're just plugging that into a calculator. So what's the height of the cloud cover? Does that sound reasonable? If you gotten 4, was that a reasonable answer? 4, that would be fog, right? So we got 1,120 feet. That's a reasonable answer. Clouds are 1,000 feet above the surface. Okay. This one is not medium. It's also not easy because, hey, if you had been given this problem on like an SAT, you're like, what in the heck is a centimeter? You would have to tease that information out just from reading it, type thing. But as soon as you saw angle of elevation or depression, you would say, well, I know there's a right triangle involved. I think you probably could tease that one out. Okay. 3 left. Adorning, not according. Adorning, what does that mean? Adorning.
It's there.
It's on it. But it's kind of like in a place of reverence. So you don't say like your shirt is on your body if it's just a shirt. You know, adorn means, hey, the necklace adorns her chest or something like that, right? It's got to have some meaning of specialness to it, right? Adorning the top of the Board of Trade in Chicago is the statue of Ceres, the Roman goddess of wheat. What does that mean to our problem?
Nothing.
Adorning the top. So what do you got? I got a building, and on the top of the building is a statue. And for those, there's the actual building. And at the top, zoomed in, there's Ceres. Ceres is holding
Something.
what is wheat in her hand? Yeah. Okay, great. From street level, 2 observations. This is a medium one. 2 observations are taken 400 feet from the center of the building. The angle of elevation to the base of the statue, which means to the bottom, is 55.1 degrees, and the angle of elevation to the top of the statue, which hopefully you understand what that means, is 56.5. And it says, how tall is the statue? Like, we're not even going to climb the building, and we're going to be able to tell how tall the statue is. All right, you're on. What are we going to draw?
Center.
A building. Okay. And at the top of the building is the statue. Okay, now what? Well, where are we looking at the statue from?
Oh,
Floor. 400 feet away.
400 feet. What do you want, left or right?
Right.
So we'll call that point A. This is your observation point. And it says 400 feet from the center of the building. We're assuming that the statue is perfectly centered on the building, right? Pretty safe assumption. So 400, yeah? Now what?
Oh, so it needs to go
From A to
the base of the statue.
to the bottom of the statue is our first triangle, and that has an angle of elevation of, is that right? 55. Yes. So 55.1 degrees. And then we have another triangle that goes from A to the top, and that angle is
56.5.
okay. Do we know how tall the building is?
We can figure it out.
Okay. How are we going to figure out the height? They're asking not the height of the building, not how far it is, how high it is to the top of the statue. They're actually asking us how tall is the statue. How the heck are we going to figure that out?
Take the height of both and subtract them.
What do you mean the height of both?
Get the height of both. The height of just the building.
So we need to find the height of the B for building HT for height.
And subtract that from the height
From the
of
red
the,
one, the big tall one.
So subtract the height of the,
No,
no,
take building height
opposite.
from
oh,
big,
that's not what you said, Jaden, but we'll go.
that is what I said.
no, it's,
Lucy immediately caught that. To the top of the statue, ST, right? So the top of the statue's height minus the building's height would be,
With just the statue.
and that's what we got to do. So how many problems is it really?
Two.
Two, because each one is going to involve its own triangle, right? We got the red triangle, we got the blue triangle, right? And for the audience, let's see what the book says. Hey, they did the same thing, except they went to the left instead of to the right. So the triangle there on the left side, right here in the middle, that's the height of the building, and this triangle right here is the height of the statue. And if we take those two and we do the subtraction, we will get the height of the statue. Make sense? Okay, you're on again. How are we going to calculate the height of the building?
400 tangent.
So tangent again. Okay, so top of the statue minus the bottom of the statue, right? We're talking about heights here. The height to the top, height to the bottom, or height to the top of the statue or the height of the building. Either way you can say that. We got to do that one thing. So bottom and top. So this is the bottom to the bottom. This is to the top. And both of them are going to involve literally the same function. The only thing that's going to change
The number and tangent.
the angle of elevation. Okay, so I'm getting 573.4 feet. Doesn't say what to round to. And to the top, I'm getting 604.3 feet. Notice the notation I use there, B and B prime. You could say B1, B2 if you wanted to as well. Does that make sense? Okay. Anybody do the math?
69.
You're just throwing a random number out. How much? Where did you get 60 from?
I put the 6 in front of the 7, and then the 5.
31 feet, roughly. Is that a reasonable answer? Usually when this goes wrong, it goes really wrong. I got a negative 12, right? That ain't going to happen. Or maybe you get 1,200, which also doesn't sound reasonable, right? Okay. All right. Hey, this is a perfect SAT question right here. Perfect. It involves just basic trig, but it's also a step up from, hey, here's a triangle, solve for X type thing, right? So they wrap it around a word problem, but it's pretty straightforward. What was that, number 4? We got 2 left. We're not going to make it to the last one, so I'm going to skip this one if I don't do this. All right. So we're going to go to the very last one. This is the one I'm skipping. This is the one that involves a lighthouse. It's in the book. Just read it because I'm giving you one exactly like that tonight for homework. Okay. The only difference is that you have to remember that arc distance is theta times the radius. Okay. On to the last one. All right. You know, every person that has a specific job, they have their own vernacular. Like they have their own words that they use to do things. And usually it's words that we don't use. So here's an example of this. All right. From a north-south line of your location, right? It's the acute measurement of the target. And we call that your bearing. So let me explain. Hey, dot 1, dot 2, right? If I go directly north from the first dot, the red dot, your bearing is the angle between the blue line I just drew and where you're going to. That's called your bearing, right? So let's see. If I measure that angle right there, we call that our bearing. So that's theta, right? The way you make that is to first go north and then the angle to the east, because I'm going to the right. If this dot was over here, then it would still be north, angle west. Okay? Could we go south? And the answer is yes. If the dot was below us, then you would go south, the bearing angle, either east or west. So this first one is always going to either be north, south, east, or west. Your second angle is going, or the second thing in the middle here is going to be the angle that it takes you to get to the thing that you're going to, that is either north, south, east, or west. Okay. Here's my first dot. Now I'm going there. So where am I going to go first? Well, I'm definitely not going north first. So I'm going to go south first. You agree that there's now an angle between this blue line and this dot. So I'm going south. That angle and this dot blue is what? To the east or to the west of the red dot. So that bearing would be south, that angle theta, and west. And this is the information that you're going to use in the last couple problems. So most challenging for last. So it says you got an airplane that takes off from an airport. It says to left. I'll explain that here in a second. And it has a bearing of north 20 degrees east. Aviation people like to do things weird. Okay. So let's see if we can draw that picture. First off, airplane 777. Chicago O'Hare Airport. And it says runway 2 left. If you don't know this, right, runways have numbers on them that align with the degrees. They just leave off the 0. So this is runway right 270, 270 degrees. So this is the runway that's facing due west, right? That is 27 right is right here. Here's west. Here's 2 of them, and it's the one on the right facing 270 degrees. So there's 27 right, as they would say in aviation speak. We're on 2 left. Okay. So let's see. Runway 2 left, right? It's only got 1 number, so that means it's 20 degrees. So 20 degrees. This is why I'm showing this, because you're not going to figure this out all by yourself. So runway 2 left is, you leave off the 0 at the end, but then it says 20. So runway 20. So the angle of the runway is 20 degrees to north. Okay, so there's the runway right here, this little red peak thing right here. Okay. It says it takes off from that runway and it flies for 1 mile. You see the triangle? So if I fly for 1 mile at point P, I've now gone 1 mile. Then it says it requests the plane requests a 90-degree left turn. So if I'm here and I make a 90-degree left turn, I'm now going in this direction. And it says I go for 2 miles. Okay. Lastly, it says, what is the bearing between where the plane took off and where it is right now? It doesn't say what's the angle, it says what's the bearing. So if I draw 2 dots, here and here is where it wound up. It's going to be north, whatever this angle is right here, and west. It's just a triangle. We're still going to use trig. All right.
20 plus theta.
You're going to have to subtract 20 from theta. Because 20 is already right here.
Yeah, but I'm saying like instead of this is what 1 mile, 2 miles.
Yeah.
What?
Abby.
No, theta is the higher angle. So once you figure out what theta is, you subtract 20, and that would give you this thing.
I thought it ended.
Well, remember, that was our first bearing.
Staring at you.
Or runway 2, sorry. All right, girls, if you have any questions, make sure you send me an email. I'll see if I can help you.
Oh, yes. Oh, you're not talking to me.
Yeah, I'm talking to.
Okay, sorry.
There's only